Hey guys, welcome back to another set. So in this one we'll be going through the old spec paper 3H. Okay, so this is actually easier than the new spec for the Jan 2019. Okay, so as always, you've seen this before. We're going to go through the whole paper and see how we do. Okay, so I'm going to jump straight in, yeah? So number one, Jerry drove 315 kilometers from London to Leeds. Okay, so that's the distance. His average speed was 75 kilometers per hour. So we're working in kilometers and time unit is hour. So before we carry on, always write the formula. So the formula for speed, distance, time is speed equals distance by time. Okay. Now work out how long it took Jerry to drive from London to Leeds. So how long refers to the time. Okay. So in this sequence, what you want to do is rearrange this to make time the subject. So we just have to swap t and s around. You're going to have now t equals distance by speed. Okay, so it's easy. Multiply time, divide speed. Now the distance we know is 315 kilometers by 75 kilometers per hour. Now when you smash this in the calculator, you're going to get a time of 4.2. Now because we're working in hours, kilometers per hour, this refers to 4.2 hours. Okay, now be careful. It says give your answers in hours and minutes. Remember, this is 4 hours, but the 0.2 does not mean 2 minutes or 20 minutes. So that's, you gotta be careful there. So in order to get minutes, we take the 0.2 bit in the count of the 4.2 or 0.2 and multiply that by 60, because we know there's 60 minutes in an hour. And when you do that, you will literally get 12 minutes. So this means that the time it took Jerry to drive from London to Leeds was 4 hours and 12 minutes. So we just write here. So therefore, t equals 4 hours and 12 minutes. All right, number two. So point A has coordinates 4 and -1. Okay, so this would be written over. Point B has coordinates 9 and 7. Work out the coordinates of the midpoint of this line AB. So this means connecting the 2 points together, let's say A and B, and we're trying to find the midpoint, let's say M. So that's literally halfway between A and B. Now the nice trick is to find a number halfway is simply add up the coordinates and then half them. So looking at the x coordinates, we're going to have 4 plus 9, which is 13, and then you half it. And then halving 13 is 6.5. For the y coordinates, you got -1 plus 7. So adding those two, you get 6. Half of 6 is 3. So our coordinates is going to be 6.5 and 3. Okay, number 3. So we got a universal set, so that's what that symbol means, of all whole numbers from 3 to 13. So in essence, yeah, if you had to copy this out properly, if that's how it looks like, you can write all whole numbers from 3, 4, 5, all the way to 18. Okay, so that's pretty much everything we need to include. Now it tells us that A, B, and C are given by the following elements. So these numbers are known as elements in the set. Okay. Now list the members, elements. List the members of the set A and B. So this means when A intersects with B, so what A and B have in common. Well, we can just see that they both have a 3, a 6, and a 9. So the things they have in common is 3, 6, and 9. Now, next bit. A uniting with C, so A union C. This means that we need to write every single element that appears in A and C without repeating. So we can see that in A, it's easy to start the first one, we have a 3, a 6, a 9, and 18. And now looking at C, we also have a 6, we don't copy it. We have a 12, which is unique, and that's it. So usually for this ones, I'm not sure if it matters to do in order, but when you do this, always rewrite it in order anyway, just in case. So you got 3, 6, 9, 12, and 18. So you got 5 elements. Okay, so Sasha writes down that 12 does not belong in A. So that's what that symbol represents. Is Sasha correct? Well, let's have a look. Let's look at set A. So A, we have 3, 6, 9, 18. 12 is not in there, which is true. So the answer is yes. And we just say A contains 3, 6, 9, and 18, but does not include 12. Okay, Easy, yeah? This is just basically your understanding of notation. So that's the point of this question. Number 4. A circle has a diameter of 18 centimeters. Okay? Work out the circumference of the circle. Whew, is that it? Give your answer correct to one decimal place. Alright, so all this is saying is that we need to know the circumference formula, which is, by the way, either 2 pi r, where r is the radius, or the circumference is pi times the diameter, d. Well, we might as well go over the second formula. Since the diameter is 18, it's just literally going to be pi times 18, so 18 pi. And I'm smashing down your calculator. So smashing this in your calculator, you're going to get 56.5 centimeters to 1 dp. Okay, number 5. So Josh has 40 counters in a bag. In the bag, there are 18 reds, 13 blues, and 9 yellows. Okay, so we're going to keep this in mind, yeah? Josh put some more red counters in the bag. Okay, so this is an important statement here. When you add more red bags, more red counters, and we don't know how many, let's say now he has 18 reds plus an additional X counters, yeah? So that means in the bag he had 40 originally, now he's got an additional X amount. The blue is still 13 and the yellows are still 9. So this is the total divided by this amount here, yeah? Now Josh is now going to take at random a counter from the bag. The probability that he will take a red counter is a half. So in other words, this means that if you're going to take a red, we know how many reds there are. There is 18 plus some extra X over 40 plus X, which is the total. And we know that this is equivalent to a half. Okay. Oh, this is a random one. Work out the probability that he will take a yellow counter. So we can work out what yellow is later. Let's go ahead and figure out what the value of X is, yeah? And once we have X, we'll know exactly how many counters are actually in the bag, and then we can work out the yellows. So solving this equation here, the easiest way to work through it is to firstly clear the fraction. In other words, multiply 40 plus X across and 2 across. If you do that, you're going to have 2 times 18 plus X equals 1 times, well, 40 plus X. Now all you want to do here, guys, is literally expand the bracket. So both sides doing that, you can get 36 plus 2x equals 40 plus x. Now moving the x's to the same to the left side and the non-x's to the right. So in other words, subtracting x, you're gonna have 2x goes down to 1x, and subtracting 36 across, 40 goes down to 4. So x is 4. That means there were actually 4 more reds added on. So this means that the total of 40 should have been now 44. And the question was, work out the probability that he will take a yellow. We know we got 9 yellows, so it's going to be 9 out of 44. And that's the answer, guys. Number 6. Okay, factorize y squared plus y. Now this literally means we have to see what both of them have in common. Well, clearly they both have a y, so we can divide y from them. And if you divide y from them, y squared, taking a y out, you're left with a single y. If you divide y by itself, it becomes 1, because y times 1 is y. And that's it, this is done. Now B, solve 3 times m plus 7 equals 12 minus 5m. Easy. Firstly, we just have to expand the bracket, so you can get 3m plus 21 equals 12 minus 5m. And now all you want to do is move the m's to the left side, so add 5m across, so you can get 8m. And subtracting 21 across, so 12 minus 21, you should get minus 9. Double checking that. Yep. And now lastly, you just want to divide by 8. So it'll be m equals minus 9 over 8. Now here, expand and simplify this double bracket. So this is just literally the FOIL method, guys, yeah? So you're going to do g times g and then g times 2. Then you can do minus 7 times g and minus 7 times 2. So doing it like that, so doing the top half first, g times g is g squared, g times 2 is plus 2g, minus 7 times g is minus 7g, minus 7 times 2 is minus 14. And always don't forget this. Now we're going to collect the middle bits. 2g minus 7g is minus 5g. So you have g squared minus 5g minus 14. And yeah, that's it. Now D, write down the inequality shown on this number line. Okay, so the way this looks, just say this is x, yeah? Let's assume it's x. Now we just have to figure out the arrows here and the arrows here. So when you have like a dot, like a circle here, which is, by the way, not shaded in, we're going to say this is not equal to that point. So this is going to be at -4. But if it's shaded in, this means that the x value also equals the 3. So be greater or equal than 3. So summary, if it's not shaded, no equal sign. If it's shaded, it includes, so equal sign there. And yeah, that's it, guys. That's 6 done. Okay, number 7. So there are 96 cards on the table. Each card is either red or black, so keep this in mind. The ratio of the number of red cards to the black cards is 5 to 7. So this means if you added these parts up, we're going to have a total of 12 parts, meaning 5 out of 12 cards are red, whereas 7 out of 12 cards are black. Okay, so this can be helpful to determine the number of cards, yeah? In your calculator, what you're going to do is write 5 over 12 times 96 to get the number of red cards, and that will give you 40 cards. Whereas if you did 7 out of 12 times 96, you're going to get 56. So just double checking, 40 plus 56 gives us 96. So all the cards are present. Now, out of these red, it says there is a circle on 35% of red cards. So out of 40, you've got to find 35% of 40 will give you the circle reds. So you can write that in your calculator. You can literally copy down 35% times 40, and it'll give us 14. So there are 14 red circles. There is a circle on 3/14 of black cards. So again, we do the same thing. So 3/14 of the black cards, we know there are 56 black cards. So in your calculator, 3/14 of 56, you can do it mentally, but don't bother. You get 12 black circles. Now, on how many of the 96 cards is there a circle? Well, adding up the circle cards, 14 plus 12, you get 26 circle cards. That's it. If they ask for a fraction, it'll be 26 over 96. But in this case, they just want how many. And that's it, guys. Alright, guys, here we go. Number 8. So on the grid, draw the graph of y plus 3x equals 4 for the values of x that range from -2 to 3. So one thing you have to observe is that this is simply a straight line graph. If you're not sure what is a straight line graph, it's basically a graph that has an x, like mx, and a plus c. In other words, you've got a single number and you've got a single x, like that. Okay, so it matches this one. So because it's a straight line graph, you naturally just need 2 points and then just draw a straight line. So let's have a look at this, yeah? We're going to ignore this kind of thing for a second. So the first thing you want to do is always rearrange to make y the subject, for convenience sakes. So what you could do is literally move the plus 3x across the equal sign to make it minus 3x. To be y equals minus 3x plus 4, or 4 minus 3x. Now all you simply want to do is literally pick a value for x like -2. So plug in -2. You get something like that to get y value, and also plug in another value for x like 3. So the reason why we do this is because we just need to find some coordinates, yeah? And when you do that, you're going to get 2 results. So someone thankfully has done it, or someone I know has done it. And literally when you plug in -2, you get a result of 10. So this gives you 10. Now if you plug in 3, -3 times 3 is -9. -9 plus 4 is -5, which is here. And that's it. So what this tells you here, that at x equals -2, so we have a coordinate of -2, this gives us a y coordinate of 10. When x is 3, we get a y coordinate of -5. And you simply just plot these two, so -2, 10, as we know, is here. And 3 minus 5, you go 3 across and drop 5 down. And simply, if you want to be extra safe, literally just find another point, or like this guy done, every point, and connect straight line. When you connect straight line, it'll cut through all the points anyway. But I always, to be extra safe, always find a third point, like, I don't know, a point between -2 and 3, like, let's say 0. So when x equals 0, we're going to have -3 times 0, which is 0, plus 4, which is 4. So this would be the fourth coordinate, 0, and that gives you a 4. And 0, 4, well, 0, 4 is there. So yeah, it checks out. Anyway, let's move on. Okay, number 9. Alright, so it's quite small. So here they give us a right angle triangle with an angle of 52 at Q and a length of 12.7 on this vertical length, yeah? They want us to work out the length of RP, so this one here. So when they give you a length to work out, just give it a name like X, yeah? So we're going to try and find the value of X. Now when you look at this one, this is just your standard textbook question, yeah? We have literally a SOHCAHTOA problem, since we have an angle on two sides. So SOHCAHTOA. And it's right angled, of course. Now all you want to do is literally analyze what lengths we have. So we're basically working with the opposite. So opposite to 52 is known as the opposite length, so O. And next to 52 is known as the adjacent. So we're naturally working with O and A. So which one is O and A? Well, only TOA has it, because this has AH and OH. So when you have TOA, it literally represents the tan, T for tan, of the angle 52 must equal opposite over adjacent. So opposite is X over adjacent, which is 12.7. Okay, now all you literally do is just rearrange to find X, and you can do that by multiplying 12.7 across. So you're gonna have 12.7 times tan 52 equals X, and putting that in a calculator, you're gonna get to three significant figures, 16.3 centimeters. All right, number 10. So Emily made 6 cakes. It cost her a total of £7.60 to make the cakes. Now she sold 2 of the cakes for £3.50 each, meaning if they were both £3.50, 2 times £3.50 is £7. Okay. She sold the other 4 cakes for £4.25 each. So 4 times £4.25, 16 plus 1 is £17. So just multiply these, yeah. So that means altogether she sold them for, if you add up the money, £24. So that's good money. That's a good return from £7.60 actually. Now work out Emily's percentage profit. Easy. Okay, so to do something like this, you can literally use the classical formula, which is the OV. 1 plus or minus a rate gives us the new value. Okay, OV is the old value, NV is the new value. Okay, where the old value in this case is going to be £7.60, representing the cost. Because it's a percentage profit, profit means you're going up. It'll be 1 plus that percentage rate equals the new value, which is how much you sold it for, £24. Okay, now all you literally do is just rearrange to find R, where R is going to be your percentage profit, yeah? So what we could do, we can just divide 7.60 across, and then you can have 1 plus R equals 24 over 7.60. Oops. And then literally minus 1 across. You're going to get minus 1. Okay, you're going to get a weird answer, yeah? You're going to get a decimal answer of 2.15, and whatever that is, multiply by 100, because they want a percentage profit. So timesing 100, you're going to get to the nearest whole number, 216% profit. Yep, you can have a profit which is really big, like above 100. Just remember, 24 is way more than double 760, so it makes sense. Okay, number 11. So here is a solid trapezium. Okay, the cross section of the prism is a trapezium. So the cross section is this front face here, and it extends all the way across. So that's why it looks like a prism on a 3D scale. Now work out the total surface area of the prism. Okay, so this is easy. You just have to look at the shape and pretty much calculate the area of every single face. Now look at this carefully. This shape is made up of 2 trapeziums, so one here and another one behind, and they're identical, by the way, of course. And you got 4 other rectangles. So you got a curved one here, one at the top, one in the back here, and one on the ground. So let's work out each area, yeah? Now the area of the trapezium is given in the front of the book, and the formula is something like half A plus B times the vertical height. So this is the area of the trapezium. Now A plus B is simply the 2 parallel lengths, like 21 and 27. So to work out this first, the formula is literally going to be then half 21 plus 27 times the vertical height, which is 8. Now because you got 2 trapeziums, we can literally just double this result and then double this result too. And if you do this, put this in a calculator, including times 2, you'll get 384 centimeters squared. So that's the trapezium done. Now let's have a look at the rectangles here. So look at the first rectangle here, so the kind of bendy one. We got a length of 30 and another length of 10. So you literally just do base times height. So 30 times 10 will give us 300. So this is 300. Now looking at the top over here, so this area here, oops, you got a length of 21, and you're going to have another similar length here, so a parallel length of 30. So this length here is 30. So the formula is literally going to be base times height again. Remember, this is just a rectangle, okay? And it's going to be 21 times 30, which is going to give us 630. Now the other two rectangles is the one on the ground, so over here, it's going to be 27 times the similar length, which is 30. So 27 times 30, and that's going to give us 810. Okay, and the last rectangle is over here. So you got 8 by, and then this length here is parallel to this length here. So 8 by 30, and 8 by 30 is 240. And that's it, guys. And now all you want to do is literally add up every single length. So 240 plus 630 plus 300 plus 810 plus 384, and you should get a total area of 2,364 centimeters squared. And that's it, guys. Literally done. Okay, number 12. So there are 40 children at the kindergarten. 24 of the children are boys and 16 are girls. Now the boys have a mean height of 113 centimeters, whereas the girls have a mean height of 110. Now they want us to find the mean height of all 40 children at this kindergarten. Now this is known as the weighted mean, by the way, guys. A very unique formula. And the way it works is very nice. So we can say that 24 boys with a mean height of 113 plus 16 girls with a mean height of 110 must give us, which is 40 with a mean height of something m. Yeah, and that's it, 40m. Now all you want to do is literally just, well, divide 40 across and find m. And that's easy. So smash this in the calculator and divide it by 40. You should get a mean height of 111.8 centimeters. And that makes sense because that falls in between 110 and 113. So Remy invests 18,000 dirham in a savings account for 3 years. Now he gets 1.2% per year compound interest. So this means that his money is going up every single year by 1.2% for 3 years. How much will he have in his savings account at the end of the 3 years? Okay, now this is very standard formula, yeah? You have the original amount, you increase it upwards or downwards, and it'll give you a new value. And because you're dealing with several years, you're going to put a power of 3 here. And that's straightforward. So then we can basically say that he invested an original amount of 18,000 and it's gone up. So use a plus value by 1.2%. All to the power of 3. And then when you do this, and by the way, they want the answer to the nearest dirham. So that means the nearest whole number. So you're going to get an answer approximately equal to 18,656. And this is being rounded upwards from 655.8. So the group frequency table gives information about the distances that 120 people travel to get to work. Okay, complete the cumulative frequency table. Now, cumulative frequency literally means that you're adding as you go along. So you're collecting the people as the distances increase. So that's why the values start from 0 to 5, and now it's going to be 0 to anything because you're including everybody from the beginning as you go up. So with the easy way to do it, start from the 8, from the very beginning. You had 8 people. Oops. So you had 8 people who traveled up to 5 kilometers. That means up to 10, you include both of these numbers, 8 and 20, which makes 28. And up to 15, you add another 27, which is 55. So just use a calculator, guys, yeah? Up to 20, you add 29 more, which is 85, 84. And keep on going, yeah? So keep doing this for the rest. Add 18, add 11, and add 7. Okay, so that was easy, 1 mark. And by the way, a little tip, yeah? Because you know there were 120 people that traveled, the final amount must be 120, which accounts for every single person. So that's a little tip to make sure you get it right. Okay, next bit. Now on the grid, draw the cumulative frequency graph for your table. So the way to plot this, you literally start like this. You have so you can say for up to 5 kilometers there were 8 people altogether. Up to 10 there were 28, and so on. So these are your coordinates: 5 to 8, 10 to 28, and so on. Now looking at this graph here, we have distance at the bottom, so we can count in So you got 5, 10, and so on. And you got cumulative frequency all the way up to 120 here. So plotting this carefully, for the first set of values, you got 5 and 8. So 5 is here and 8 goes up to, so this is going up in 2s, yeah? Oh, why did they do this line? 5 and 8. Okay, next one would be 10 and 28. So 10 and 20, oh, 20. Yeah, this is going to look weird, by the way, but you get the idea. And we're going to do this all the way across, yeah? 10, 28, 15 and 55. Okay, and then when you do all of this, don't forget to put a plot as 0, because this means that for up to 0, nobody traveled it, because, you know, no one traveled up to 0. Okay, and then all you do now is just connect this and try and draw an S-shaped curve, yeah? So it's going to be quite hard for me because it's a computer. I'll try anyway. So it looks like this. Alright, not too bad, not too bad. Now finally part C. So use your graph to find an estimate for the interquartile range of the distance traveled. Okay guys, when you see the final answers, it's going to look slightly different. So I'm just going to show you the method and I'm just going to hope it's right because I don't have the mark scheme at the moment. So interquartile range. This literally means the difference between the upper quartile and the lower quartile. So that's what interquartile means, the difference between the quartiles. Now the upper quartile is literally the third quarter of all your people. So because you got 120, you literally need to find the third quarter, so 3/4 of 120. Doing this in your calculator, you'll get 90, which is here. To find the lower quartile, it's the first quarter of 120. And of course, 1/4 of 120 is 30, so that's about here. Now all you literally do is extend the line across. So again, this is not going to be really accurate, but I'll see how that goes. And then you extend it downwards. So I'm just going to drag the mouse like this. Ooh, okay, you get about 20 actually. That's nice. Let's just say it was 20, yeah? And then for 30, again, same thing applies. And then shoot it downwards. You know, I'm just going to do it like that. Okay, you get about 10. Alright, so this is going to be kind of weird. So tell me what you guys get as your final answer, yeah? So you can say that the interquartile range between 20 and 10, so you subtract them. 20 minus 10 is 10. That's it. Okay, number 15. A. Simplify g to the power 8 divided by g to the power 2. So first things first, when you divide terms, you subtract the power. So it'll be 8 minus 2 is going to be g to the power 6. Okay. B. Simplify 6e squared m7 times 3e m to the power 4. Now you just take this term by term. When you multiply, you add the powers. But as for the whole numbers, you just hit it head on. So 6 times 3 is 18. E squared times e, you add the power, so it's like 2 plus 1 is e3. M to the power 7 times m to the power 4, again you add the powers, so it'll be 7 plus 4, which is 11. So m to the power 11. Yep, that's done. C. Simplify all of these lot to the power of half. Now that's not too bad. When you have everything to the power of half or anything to the power of something, you distribute this power to all the terms. So it's gonna be 64 to the power of a half. And then A6, stick a half next to it. And then C2 and stick a half next to it. Now you just expand it. So 64 to the power half, you can smash in your calculator and you'll get 8. That's basically the square root of 64. 6 times a half is 3, so 8 to the power 3. And then 2 times a half is 1, so c to the power 1 or just c. Okay, good. So that's done too. Now D. Factorize x squared minus 1. So when you see an example like this is known as because you can't factorize this the standard way because there's nothing in common. So this is an example of DOS, which is difference of two squares, okay? You have a square term minus another square term. And when you get that, you get instantly a double bracket solution. So this is important to know. Now what goes in both of them? Well, you need two terms that are times to make x squared, or if you square root it, you get x and x. And if you square root 1, you get 1. So the solution would be x plus 1 and x minus 1. It's always going to be plus and minus, and the terms are going to be the same. Alright, E now. Make k the subject of this function where f equals the square root of 1 minus 2k over 3. Now first things first, before we even do anything, let's clear that square root to make it look a bit better. So to clear the square root, we need to do the opposite, which is squaring. So square both sides, you get f squared equals 1 minus 2k over 3. So the square and square root cancels out. Now next step you want to do is clear the fraction. So multiply 3 across, so you get 3f squared equals 1 minus 2k. Now we're almost done. You can see that this is not too bad to do. Now I like to make my subject terms positive, so I'm going to plus 2k across and minus 3f squared across. So you get plus 2k equals 1 minus 3f squared. And lastly, to separate the 2 from the k, just divide everything by 2. So you're going to get k equals 1 minus 3f squared over 2. And that's your answer, guys. Okay. Alright, number 16. So the diagram shows triangle PQR. Okay. So it looks like we have a small triangle and we have pretty much an identical similar triangle which has been expanded. Now let's have a read. A is a point on PR, which is here, and B is a point on QR over here, so that AB, this line, is parallel to this line PQ. Alright, good. So we're given some measurements, which is also here. Work out the length of AP. So we need to work out this little length here. Now there's a nice trick here. The way these kind of triangles work is that these are known as similar triangles, okay? So we have a small triangle here and a massive triangle there. And it helps to re-sketch the diagram. So you got a small triangle here and you got the similar sized one over here, where you got 6 at the bottom and you got 5 on the left. But then you also have 15 at the bottom, and then you want to find some length on the left, well, part of it. Now the trick is, because it's similar, we need to find the common scale factor, yeah? And to find the scale factor, pick 2 common lengths like 15 and 6 and then divide them. So in your calculator, you're going to write 15 divided by 6 to find the scale factor of 2.5. So this tells us that all the lengths from these 2 triangles have been multiplied by 2.5. So therefore, if you want to find this length here, which is part of AP, you just do 5 times 2.5. And if you do that, you're going to get 12.5 here. Now that's the length of the full thing from R to P, yeah? We know part of it is 5. I know it looks kind of weird, but this length is actually longer than it should be. The total length is going to be 12.5, so subtract it from 5 to get the remainder, which will give us 7.5. Okay, and that's it. The length of AP is 7.5. Now, next bit. Given that the area of the triangle PQR, so PQR is basically PQR is the whole shape, so the big shape has an area of 88 centimeters squared. Work out the area of ARB, in other words, the small triangle. Now, again, this is also to do the scale factor. Now, one thing you want to be careful is to not divide 88 by 2.5. This is a scale factor of a length. You need to find a scale factor of an area, which is the scale factor squared. If you had volumes as well, it will be scale factor cubed, which will be 2.5 cubed. So in your calculator, you're going to put 88 divided by 2.5 cubed. And when you do that, you should get a full answer of, let's see, 14.08. And yeah, that's it. So use algebra to show that the recurring decimal over here equals this fraction. Now, to prove anything, and when they say use algebra, they literally tell us, all right, we need to always let this equation equal something like x. So x equals 0.024 recurring. But instead of just writing recurring, I'm going to just actually recur it, okay? Just a bit. So I'm just going to show you a demonstration, and that should hopefully help. So multiplying this by 10, like powers of 10, you're going to get decimal in one place, so it'll be 0.242424 and so on. And the key idea is to keep multiplying by 10 until all the numbers line up in the same position. So for example, if I times it by 10, again, I get 100x. And then times this by 10, you get 2.4242424, so on. Now, one thing to note, we look at all 3 equations and we ask ourselves, okay, so where do the numbers line up anywhere? And yes, they do. They line up over here. You can see we've got 2,4 in the second and third decimal place and 2,4 here. And again, they're the same for the rest. Unfortunately for this one, they're not lined up properly because 2 doesn't line up with 4 at all. It doesn't line up with the right numbers. So we take the 100x bit and the x bit. So we subtract both equations here. So we say, all right, 100x take away x is 99x. And then more in subtracting these long extended decimal, you'll realize that all of these will cancel out if you subtract from each other. And all you're left with is 2.4 take away 0, which is 2.4. Yeah, we're pretty much done here. And then you just solve for x by dividing 99. So x equals 2.4 over 99. And just to be sure we're right, put down your calculator and then you should get an answer of exactly 4 over 165. So that's really it. Alright, number 18. So we have three different vectors, and if you're not sure how the vectors are represented, the top number represents the x values moving horizontally like across, and the bottom values represent the y axis, so going upwards. So this A would tell us that we've got a vector that's positioned 5 to the left and 6 up from the origin. Now let's just look at what the question wants. So A, write 2 times b minus c as a column vector. So literally just multiply this vector b by 2 and then subtract from c and then combine it. So times in the first vector by 2, you get 6 and 4. And we're going to minus it from vector c, so 4 minus 2. And now this is just like normal subtraction, but in this case you subtract across. So be careful you don't do it like fractions. There is no common denominators here. There is no denominators even. So subtracting vectors, it would be 6 take away 4, which is 2. And then 4 minus 2, so 4 plus 2 is 6. And that's all they want. Okay. Cho says that the vector a minus b, so subtracting these two, is parallel to vector c. Is Cho correct? Now, to show something is parallel, you literally need to show that a vector is proportional to another vector. In other words, it's just the same thing but multiplied by 2 or 3. But let's have a look. Let's subtract a. Let's do a minus b and see what it looks like. Yeah. So we got. Let's write down here. So we got minus 5 and 6 minus the b vector, which is 3, 2. If you subtract them, so minus 5 take away 3 is minus 8. 6 take away 2 is 4. Now looking at vector c, we got 4 minus 2. So c is 4 minus 2. Now looking at both of this, you can kind of see that this vector here, a minus b, is sort of double, but not exactly double. It's a negative double. So we can rewrite this as minus 2 times 4 negative 2. So to properly answer this question, is Cho correct? Yes. Reason being is that a minus b is minus 2 times bigger than c, and they're both moving in the same direction of 4 and minus 2. Alright, express this fraction, both of them, as a single fraction. Give your answer as simply as possible. Now one thing you have to notice is that we are subtracting two different fractions. So the first rule is when you add or subtract is to get common denominators, yeah? Now to make them common, we just need to stick what they don't have. So the first one does not have an x plus 5, and the second bit don't have an 2x plus 1. So that's what you're going to do. You're going to times the left side all by x plus 5, up and down. And you times the right side by 2x plus 1, up and down. Let's do that, yeah? So times it up and down by x plus 5. 1 times the x plus 5 is just x plus 5 over, and then just stick x plus 5 times 2x plus 1 together. And now the second fraction, again, is going to have the same common denominator, so x plus 5 and 2x plus 1. You're going to times the top also by 2x plus 1. So it'll be 3 times 2x plus 1, which is 6x plus 3. Okay, now we're almost done here. So now we just combine it. Now, because you're subtracting, you just literally subtract terms. So it'll be x take away 5x, which is minus 5x. And 5 take away 3 is 2. So it'll be minus 5x plus 2. But I'm going to put 2 in front because it looks better that way. And all of this over x plus 5 and 2x plus 1. Now, just to make it clear, you literally do not have to, expand the bottom half of the fraction. You could leave it like this and you should be good. Alright, part B. Solve the inequality 6 times x minus 1 squared greater than 24. Alright, to do something like this, literally forget you're dealing with inequalities. Just treat it like an equal sign for the time being. So rewriting this, we're going to have 6 times x minus 1 squared equals 24. And now we're going to go ahead and simplify this quickly, yeah? So we're going to firstly divide 6 across. We're not going to bother expanding this, yeah? So you get x minus 1 squared. Divide this by 6, you're going to get 4. And now to get rid of the square, we need to square root both sides. So you're left with x minus 1 equals the square root of 4, which is 2. But because you square root, it will be plus minus 2. Now lastly, we're going to add 1 across. So we're going to have x equals plus minus 2 add 1. Which is what it's trying to say here is that if you chose the plus version, you're going to have plus 2 plus 1, which is 3. Or if you start with minus 2, you have minus 2 add 1, which is minus 1. Okay, so you have two solutions to x. Now this is not the answer they're looking for. They're looking for inequality values. Now the point of this is known as our critical values, yeah? And using our critical values, we're going to construct a little table like this, put this in ascending order, so minus 1 and 3. And we're going to test an x value between it to see where it's true, where the inequality is true. And I'm going to show you this method so you can use it in the exam. So let's pick a value between minus 1 and 3. Let's say 0, because 0 is always good. So when x equals 0, you plug into the original equation. So you're going to have 6 times 0 minus 1 all squared. So it'll be 0 minus 1 squared. And what does that give us? We're going to check if it's bigger than 24. Well, 0 minus 1 is minus 1. Square, you get 1, you get 6. And of course, this isn't bigger than 24. So this side is false. So what this tells us is that the inequality is not between minus 1 and 3. It's away. If this side is false, this is automatically going to be true. And therefore, you're going to have x values which are less than minus 1, which fits this side. Or x value which is greater than 3. So these are your results. Okay, and that's it, guys, yeah? If you have any questions about this, let me know in the comment section, yeah? Okay, number 20. So we've got A, B, and C are points on the circle. So we've got A, B, and C with center O. So this means these lines up next to it are the radiuses. So a radius here and a radius there. Now TAP is a tangent to the circle. So here's TAP. Now when you have a tangent, this is literally important. Always connect a line from the tangent to the center circle, because immediately we're going to have a right angle triangle on both sides, or right angles from it. So this is a default reason, yeah? Now, TBOC is a straight line, so this is also important. So we've got T to B to O to C, and angle ACT is 29 degrees. So the aim is to find the value of x here and give a reason for each step. Okay, so I'm going to just give the reason verbally, yeah? And I'll try to write some of it down. So the first thing you want to do is firstly notice that we can form a triangle from ABC, and that's very important too. So I'm going to just use a blue pen. So here's triangle ABC. Now the significance of this is that when you have a semicircle, when you have a line cutting straight across a diameter, you can see that this cuts off half the semicircle or half the circle. So when you have a semicircle, the angle opposite the semicircle is always right angled here. So we have a right angle triangle inside a semicircle. So we can write that down. Semicircle, therefore angle CAB is 90 degrees, it's right angled. So this is one property. So if this is 90 degrees, you can easily work out this angle here, which is going to be 90 plus 21, and minus it from 180 will give us 61 degrees. So all of this must sum up to 180. So triangle ABC adds up to 180 degrees. So it's good to just put these points down. Now another thing to note here, yeah, and this is probably more of the tougher theorems, yeah. Let me just delete this for a second, yeah, these little red marks. Now there's something known as the alternate segment theorem. So this is quite important. Alternate segment theorem. Now you always get this when you have a tangent and a chord. And what that tells us is that the angle between the tangent and the chord is equal to the angle opposite the chord, which is over here, which is 61. So this angle is 61 by default, yeah? So we say therefore angle PAC is 61 degrees, which is equal to angle, what was that I said? ABC. So this is the alternate segment theorem, yeah? So the angle from between the tangent and the chord is equal to the angle on the other side of the chord, which is at point B. Okay, so that's the reason why that's helpful, is because when you get that, and because we already established that this is 90 degrees, we can work out the angle on the other side. And we know that the angle on a straight line adds up to 180. So basically I'm saying all the way across. So you've got 61 here, you've got 90 here, And if you add these up and subtract it from 180, well, you'll get 29 as well. So that's another one. Now the last one, and you'll probably see this now, in order to get x, we're going to deal with this last triangle here, ATB. Now another good thing is that we already know that at point B we got 61 degrees. So if we want to work out this angle here, this is the angle across a straight line, yeah? So let's minus 180 from 61. So you do that, you're going to get 119 degrees. So almost done. So now we have a triangle of 29, 119 and x. And all angles in a triangle must add up to 180. So let's add 29 to it and then minus it from 180. You should get a remainder of 32 degrees. And that's it, guys. Your x is 32 degrees. Alright, number 21. So the functions f and g are such that fx equals this and gx equals a fraction. Work out f at the point 3. So you literally just replace x value of f with 3. So you're going to get f3 equal to half times, instead of x, 3 plus 3. And putting in your calculator, you should get 9 over 2 or 4.5. That's it. B. State the value of x that cannot be included in any domain of g. Now, when they say domain of g, that literally talks about the values x you're allowed to use. Now, there's a common rule here. If you have a fraction or a square root, you can only use certain values. With a fraction, you can't divide anything by 0. With a square root, you can't take the square root of a negative number. So in terms of g, we can say, alright, the bottom half cannot be 0. So 2x minus 3 cannot be 0. So now we just have to solve this and make x a subject. So you can just plus 3 and divide by 2. So x can technically not be allowed to be 3 over 2. So every value x works except this value. So the value that we cannot include is x being 3 over 2. That's what we cannot include. Now finally C. Oof, this is a big one. Solve f minus 1x equals g of x. Now this f minus 1 is the inverse function of f. So firstly we look at f and we go replace it with its inverse and equate it to g of x. So this is going to be a big marker, 6 marks, and this will take a while. So first things first, we need to work out what the inverse of f is. So let's rewrite it here, yeah? So to calculate inverse, a nice trick is to replace all the letters of y. So we have fy equals half y. Instead of writing half y, I'm going to write y over 2 plus 3. And the one property of the inverse that you make it equal to x. And then you rearrange this to make y the subject. And this is easy to rearrange. You simply minus 3 and then times 2 across. So y equals x minus 3 times times 2. Okay, that actually looks really bad. So to simplify that, it will just be 2x minus 6. And this is going to equal the f inverse function. Was 2x minus 6. Now how about for g of x? Okay, so what this tells us is that the function of f enters g. So when I say enter g, it means you replace this x value with the entire f function. So I'm going to need a bit of space for this one. Okay, so I've copied it here. So let's expand this carefully, yeah? So you can have 14 over, so expanding this by 2, you're going to get 2 times half x, which is x, and 2 times 3 is 6, minus 3, which is plus 3. So that's what it becomes. So that's g of x. So 14 over x plus 3. Now it tells us solve this equation when you equate them together. So let's do it. So we're going to have 2x minus 6 equals 14 over x plus 3. And from here, let's see. The first rule is always clear the fraction. So to multiply x plus 3 across. So you're going to have 2x minus 6 times x plus 3 equals 14. Oof, this looks like it's going to be a hard quadratic. So now we're going to expand the bracket. Let me just change my pen. Okay. So we're going to do 2x times x, 2x times 3. I didn't even change it. And then minus 6 times x, and what's the last one? Minus 6 times 3. So let's times it out. So we're going to have 2x times x is 2x squared. 2x times 3 is plus 6x. Minus 6 times x, oh actually this is nice, minus 6x, so they cancel out. Minus 6 times 3 is minus 18, and this equals 14. Alright, nice. So now lastly, what we're going to do here, we're now going to just make 2x squared the subject. So let's plus 18 across. So you're going to have 2x squared equals 14 plus 18, so you get 32. And then you half it across to make x squared the subject, you get 16. And lastly, to find x, we need to square root. So x would equal plus minus 4. Now to check if which x value is correct, it says here that anything about x, is x positive? Nah, it doesn't say anything about x. If it doesn't tell you anything about x, then the answer is plus minus 4. If it tells you x is negative, then minus 4, x is positive, plus 4, and so on. Alright, number 22. So the diagram shows a parallelogram LMNP where some lengths are given. And they tell us that ln equals 13.3. So that's this line across here, yeah? So I did it now. They want us to calculate the area of the parallelogram. Now the one thing to note is that the area of the parallelogram is not very obvious. However, you probably see that after splitting this parallelogram into two identical triangles, we can work out the area of this triangle here and just double it to get the whole parallelogram. Now to work out the area of a triangle, there's one special formula, which is half AB sine C, and I believe you get this in the front of the book anyway. Where A and B would be, where sine C would be the angle between two lengths A and B. Now this is good for this formula here, but before we even attempt this formula, we need to figure out what this angle C could even be. Now the only way to find the angle, this angle here, let's just call it alpha. Let's just call it x for the sake of it, yeah. Is to use the cosine rule. Now to use the cosine rule, you can only use it if you have 3 lengths and an angle you're working with, which is what we have. To use the sine rule, you need 2 matching pairs of angle and lengths. So basically we're going to use the cosine rule here. Now the cosine rule formula is like this. It's a squared equals b squared plus c squared minus 2bc cos a. Now you notice that we're not using these letters, but the key thing is to label this appropriately. And always update it when you use the cosine rule. So B and C is going to be the two side lengths like here. So this is B and this is C. Now capital A would be the angle, and this is the only angle we have, so it has to be here. And opposite the angle would be the little length A. So that's it. So we know our A is 13.3. We got our B's and C's, and we got angle capital A. And we also have a variant formula, which is basically if you want to calculate angle, which is cos A equals B squared plus C squared minus A squared over 2BC. And this is the formula I'm going to be using here. Reason why is because we want to find the angle. So therefore we can replace everything you know. We have cos x equals B squared, so 7.5 squared plus 14.6 squared minus A squared, which is 13.3 squared over 2 times B and C. Okay, now have a go. When you do this, you'll get something like, let's see, cos x being about 0.422 dot dot dot. So all you want to do now is literally shift and cos inverse the answer. And when you cos inverse it, you'll get an angle of about 65 degrees, give or take, yeah? And that's perfect. So now we know the angle of this part. We could just use the area of a triangle formula. So half AB sine C. And again, the best thing to do is always relabel this, yeah? So when you're doing this by hand, always redraw every single diagram. So we can say that therefore the area is going to be half AB, so these two opposite lengths, so 7.5 times 14.6 sine C. And C, we just calculate the angle to be 65 degrees. Okay, and because we're trying to find the area of the parallelogram, we're going to just double this answer, so times it by 2. And when you do that, you should get an area of 99.2 centimeters squared. And that's it. Alright, 23. So they give us the equation m equals b minus c over a. And we have 3 different variables, all rounded or correct to 1 decimal place. Calculate the upper bound for the value m. Okay, so this is just bounds and error intervals. Now, when they say something like correct to 1 decimal place, this means that the values could have been anywhere between 2 decimal places or more. So what we do, for example, for part A, we just set some bounds like this, And it's always less than and equal to the left side or just less than some upper value. So for 5.3, the value could have been anywhere before it, so something like 5.25 or more, because if you round that you get 3, or it could have been just less than 5.35 but not 35 exactly. And we could do the same things for B and C. So we put less than or equal, less than or equal, and less than for the upper bit. For the B bit, instead of 0.6, it's going to be like something like the upper bound be 346.65, and instead of 65 will be 55, so 346.55. Same thing for C. Instead of 80.0, it will be 80.05, and if you're going to go back a bit, it will be 79.95. Again, all the same bounds, yeah? So it's just plus or minus 0.5 for everything, yeah? So plus minus 0.05. Okay, not bad. Now, let's actually answer this question, yeah? So calculate the upper bound for the value of m. So to get the upper bound, when you're dividing fraction, you want to find the greatest ratio. So m would be, so the upper bound of m is going to be the upper bound of the top half over the lower bound of the bottom half. The reason why, if you reduce the denominator as small as possible and increase the numerator, you're going to get a really big value. If you did it the other way around, you get a small value. If they were the same, it's like no difference because they cancel each other out. So in this case, to get the upper bound of b minus c, just like division, you want to find the greatest width. So to get the greatest width, you need the upper bound of b minus the lower bound of c, all over the lower bound of a. And that's it. And picking the correct values, the upper bound of b is this one, the lower bound of c is here, and the lower bound of a is here. And you just smash this in the calculator. So you're going to have 346.65 minus 79.95 over 5.25. And therefore you get an answer of about 50.8. Okay, not about, exactly 50.8. And that's it, guys. Alright guys, welcome to the final question of the paper. And probably the very final 3H you'll ever see. So let's check it out. So there are only 3 white and 5 black counters in box X, whereas in box Y you have 4 whites and 3 blacks. Okay, let's keep this in mind, yeah? Now Michael takes at random 2 counters from box X, so any of these two, puts them in box Y. He then takes 1 random counter from box Y and puts it into X. Okay, work out the probability that there is now an equal number of white counters and black counters in box Y. Ooh, okay, so this kind of question is all about counting carefully, yeah? So let's have a look. So let's see possible ways of getting exactly the same number of whites and blacks in Y. So if you had to take 2 counters from here, let's say we took 2 blacks, yeah, and put them to here. You're now going to get 5 blacks and 4 whites. And then you can take 1 black back. So then you have 4 and 4. So we can say, alright, you can say Michael could firstly we'll take 2 blacks first in box X, meaning you're going to have 5, and then Michael can then take 1 black and put it back in X. So that's one option. So that could be in terms of probabilities. So X, oh yeah, X is out of 8 by the way initially, and this is out of 7. So let's just do the maths here. So taking 1 black first, you have 5 already. So 5 out of 8 times, now you have 4 out of 7 left in box X. And in box 7, you now have technically 9. So now you have, it's kind of hard to imagine. So you got 2 blacks already here. So you got now 5 blacks and 4 whites. If you can take a black and put it back, you have a 5 out of 9 chance of picking a black. So this is one example. There are more combinations by the way, guys. And the idea is to work out every single combination and then work them out and then add them up, the probabilities. So let's find another combo. So let's see. So, okay. So suppose we take whites now, yeah? What you could do, you could take a black and a white. So now you have 5 whites and 4 blacks. And you take a white back and you got 4 and 4 again. So that's it. So you can take a black and a white, making it 5 and 4, and taking a white back. You could also do it in this way as well. You can also take a white first and then a black and then give white back. So these two are going to give you the same answers by the way, yeah? So these are the same. So if you work one out, you work the other. Is there any other combinations? What if you took 2 whites? If you put 2 whites here, you're going to get 6. Nope, no chance. So you can't choose white. So these are your results. Now all you want to do is just put some probability values on them, yeah? So probability choosing a black first, you got 5 out of 8 again. And now you got 7 left. Probability choosing a white, you got 3 out of 7. And now, if you put this in this box, you now technically have, I have to count this carefully. So you got an extra black and an extra white now, yeah? So this means we now have, to choose a white, you got 5 out of 9, yeah? Remaining. Is that right? Yep. And then this will be the same as above. Now, yeah. Now all you want to do, guys, is literally just calculate these probabilities and then total them up. So let's do each one, yeah, step by step. Okay, so when you put this in the calculator, you should get 25 out of 126. By the way, guys, I think this is correct and I haven't checked this, so I would like to hear your answers for this. And the second one below, let me just change that 4 to a 3. Yep, and you should get 25 out of 168. And again, the bottom one will also be 25 out of 168. Now all you do is literally add all these up, and you should get a total probability underneath. And then you get a total probability of 125 over 252, which is, by the way, in terms of in terms of decimal, it's about 0.496. So roughly 50%. Nice, you got half chance, ironically.